Maximum volume for given surface area. An open top storage bin is to have a square base and 4 equal sides. If 108 meters square of wood is available to build the bin, find the dimensions the bin should have to maximize the volume it can hold, right? So we have a square base box, right? It's kind of like this. So, well, that means square base is like this, right? So we have a box here, but it's kind of open. It's open from the top. So it says square base box, and we know the surface area. The surface area is 108, and remember, it's open from the top, okay? So let's assume one thing, that the sides of this box are x units over just meters. So it is x and x here, and let the height be h. Okay, now from here, what is the surface area? Since we are given the surface area could be written as area of the base, which is x square, plus area of 4 equal sides. So area of 4 equal sides is x times h. So that is the surface area. And the surface area is given to us as 108. So 108 is equals to x square plus 4xh. Now from this we can find what height is in terms of x, correct? So we'll isolate h from here. So we get 108 minus x squared, and then we'll divide by 4x. And that gives us height h. So that is the surface area. So that is height h in terms of x. Now, what we need to do here is find the dimensions the bin should have to maximize the volume it can hold. So we are looking for maximum volume, right? So what is an expression for volume in this case? Volume is base area times height. That means x squared times height. So we can write this using the formula. So we get x squared times 108 minus x squared over 4x. So that becomes the volume. Now it's a good idea to simplify this expression. So we can see that x squared gets cancelled with x, and then we can divide by 4 and simplify it. So we get 108 x over 4 minus x cubed over 4. So that is the volume for us, correct? Now we'll find derivative and then solve for maximum volume, correct? So we have volume as equals to 108 divided by 4. 4 times 2 is 8, and then 28 is 7. 28 is 7, x minus x cubed over 4. So this is a equation one variable, and we can differentiate with respect to x on both the sides. So we get dv over dx as equals to 27, and this is minus 3 over 4 x squared. Now the critical thing here is, the critical number here is when dv dx equals to 0. So we'll equate this to 0 just to find what? Critical number, right? So we are trying to find critical number here. So that will give us, let me write down, critical number. So to find critical number, we'll equate dv dx equals to 0 and then solve for x, correct? So we get 3 over 4x equals to 27, x squared, sorry. And so x is equal to 27 times 4 over 3 square root. That is what it is equal to, right? So this is 27 divided by 3 is 9. So 9 times 4 is 36, and the square root of 36 is 6. So we get 6. That's good value. So we get a critical number, x equals to 6. So that is one value to check. The second thing which is very important to check here is what are the dimensions, what are the possible dimensions for this, the boundary conditions, right? So the boundary conditions here is that in our equation of volume we have 108 minus x squared, right? So the boundary condition is that this quantity cannot be negative. So that means that 108 minus x square should be greater than or equal to 0, right? It cannot be negative. And that means, what is the square root of 108? Let's do that. So we do square root of 108, which is equals to approximately 10.4. 10.4. So when we take it here, the sign changes. So x is basically, we say 108 is greater than or equals to x squared, and when we square root it, so we get 10.4 is greater than or equals to x, right? So basically x is between 0 and 10.4. So we have a range for x, that is, it is between 0 and 10.4, right? So 10.4, I should write square root of 108 to be precise. That is a better value. I should write square root of 108 to be precise, correct? Now, so those are critical numbers. So to find that the maximum volume, to be sure that the volume is maximum, what we can do at this stage is find the value of the volume at x equals to 6, volume at x equals to 6, at x equals to 0, and volume at square root of 108. All these three volumes, correct? Now, if you plug in this value here as 0, 0 times anything will give you 0, right? So this will be 0. And 108 minus square root of 108 square will make that 0. So these are zeros, right? So that is the volume which you get. And when you plug in 6 here, you get a value which you can calculate and write down, correct? Which is definitely a positive value. Now the question is, find the dimensions of the bin, right? So dimensions means you need to find height also, correct? So we are getting back to that, and then we'll find the volume later, right? So if x is equals to 6, then what is height equals to? So if you remember, we have used this formula here. We'll use this equation now and find what h is equals to. So we know height is equals to 108 minus 6 square, which is 36, divided 4 times 6, let me write 4 times 6, right? And we can use calculator to calculate this answer, right? So we have 108 minus 36 equals to divided by 24, and we get 3. So the height is 3 for us, correct? So we know height is 3, and now we can use this formula, correct? X squared times height. So volume at 6 is square, which is 6 square, times height, which is 3, correct? So it is 3 times 36, 108. So we get a volume of 108, right? So we get a volume when x is the width as 108 meter cube. Correct? So that's the volume which we get. It's kind of same as the surface area. That's interesting. So we can give our answer as the dimensions are that the sides of the base is 6 meters. So 6 meter by 6 meter by 3 meter. Right? That's the height. So that is the answer for us. Have a good look at it. And we get same as the surface area. That is very interesting. Thank you.